Hello again, statistics students. Let's continue our discussion of frequency distributions and the different ways of graphing them. Again, we're going to rush through this so that you can pause and just copy the notes down. I'll give a brief explanation here in this video, and the lion's share of the instruction will be in class. So we have two types of histograms we can look at here. The generic frequency histogram is explained on page 44 of our text. And on the x-axis, we mark the class boundaries, and the y-axis, how high those rectangles are. That's our frequency of data in each of the classes. There's also a relative frequency histogram. What is the only difference between those two histograms? There's only one. Okay, if you can't answer that right now, be sure to raise your hand in class and get that clarified. There is something I want to clarify in the book on page 44 of our current book. On the definition of a frequency histogram, the bottom part says consecutive bars must touch. I disagree. And I give an example here. These are consecutive bars. It's not the bars that have to touch because you want to show the gap here if there's no data, but consecutive intervals touch. There's no gap between intervals. So you may consider that being picky, but to me it's being precise. When you create a histogram, you can, on the x-axis, you can mark either class boundaries or class midpoints, but not both. And you can look at the two graphs at the bottom of page 44 of our current textbook. They represent the same data set. Just one of the histograms, it's marked with the class boundaries. The other one is marked with the midpoints of each interval. Histograms are only for quantitative data, because you're talking about the x-axis here, and we have numeric intervals. Again, when you are identifying where these rectangles are, you can mark either the class boundaries or the midpoints, not both. The key thing about histograms is those intervals have to be evenly spaced. Those classes have to be evenly spaced, equal widths. Now I would refer you back to John Grant's data, where all of his intervals equally have equal widths. Go back and take a look. Might that be on the quiz? There aren't very many times you want to use the midpoint of something, and I won't ask you to spend a lot of time on everyone's favorite, the frequency polygon. It's explained on page 45 of your text. I don't recall that I have ever asked a question about a frequency polygon on a test or quiz, but I want you to know how to read it. It graphs the very same information as a histogram. The catch is the x-axis must show the midpoints of each class. So that's one of the times where the midpoints are helpful if you need to make a polygon. And the graph starts and ends on the x-axis. And let's see if I have a histogram here. If I have a good histogram. Yes. So in a frequency polygon, you would go one more interval over here, and you'd start on the x-axis at 0 at the midpoint, and then your polygon would go up to this midpoint, this height here, midpoint, over to here, over to here. In this interval, it would it would come down to here, up here, and then back down to 0. So it always starts and ends on the x-axis. Again, don't want to spend an inordinate amount of time on the frequency polygon, far more interested in histograms. If you have questions, make sure you get that information clarified during class. It's now Friday of a 3-day weekend. I'm going to call it quits, go home and enjoy myself. Hope you're doing the same. Have a great one.